Thank you and good morning, everybody. So, welcome at our institute, Institute for Integrated Circuits here in Nuremberg. We have more than one sites here in this location, this area. Nuremberg along Fürth is a big area. We are today here in our Nuremberg office, Norostpark, and I welcome you on behalf of Professor Dr. Heuberger. Unfortunately, he went sick, so I have to take over. So we have to improvise a little bit. Hope you enjoy. Yeah, welcome to our camp. I just wanted to introduce you a little bit what's behind the Green ICT Camp. And especially we have an organization called Research Fab Microelectronics in Germany, who is driving this project, who is also responsible for this camp, who is taking care about this camp. So why is microelectronics so important today? It's really a critical component meanwhile, semiconductors. If you look back a few years, the first cars, not electrical, it's conventional cars, Porsche in 1978, there were only a little semiconductors in. Eight pieces, one electronic unit. Most of it was mechanical. There was a conventional drive. And today, if you look to that, complete electric car, 50 to 90 electric control units, and more than 5,000 semiconductors. Could you imagine? So that's really, I would say, a critical component. And if you look around worldwide, we have a lot of semiconductor factories, and also the countries, Europe, Germany, they're investing a lot because of the relevance of the technology of semiconductors. And also, we as Fraunhofer take a role there. And you see also that the future is also moving forward, going from analog designs to whole integrated sensors, and now we are talking about also special hardware, neuromorphic hardware for AI, and also quantum computer, which will drive the future, the technology. Yeah, what's about Research Fab Microelectronics? It's the organization in Germany bringing the most important research organizations together in the field of microelectronics. All in all, it's about 15 institutes, 13 Fraunhofer institutes, plus Leibniz Association. And they are all working in the area of microelectronics in Germany. And the idea of the Forschungsfabrik is to bring them together, bridging the gap between the basic research. Fraunhofer is always applied research, so we're bridging the gap from university, basic research, to application, to customer-specific product design and development. We're also providing a broad range of materials and technique to innovation solutions. We have also a unique range of expertise and infrastructure, so we have also infrastructure to do research, very expensive, very powerful fabs, tools, whatever. And our mission is also to drive the digital change and future key technologies. And we also want to support innovators and startups. And also, we want to teach you to be the future of this technology. So here you see the institutes which are part of the Research Fab. You see a lot of institutes working in this area. So we have the EAF, Applied Solid States. We have an institute, ISEC, for integrated security. Security is important on semiconductor level. We have the institute ENAS, which is working on nanosystems. Then we're also working in the field of high-frequency radar systems, which are important in electrical vehicles, but also for communication. Frequencies are going more up and up. Then our institute, Integrated Circuits, we have a broad range of IC design. We have no technology here, that's very important. So we only have design capabilities, but we also working a lot in the application area. Then we have co-located here the institute ISB, which is also in Erlangen, but they really have technology. They're working very close to power electronics for electronic drives. We have the Institute EMS, working on microelectronics systems, also AI. Institute for Microstructure Materials. Then we have also microsystems, solid state, EMFT. They're also working in the field of microelectromechanical systems, so mechanical systems on semiconductor values. Then we have Heinrich Hertz Institute, very deep in telecommunications, 3GPP, so cellular communication, photonics, optical communication, very important, silicon technology, ESIT, also working in the field of MEMS. And last but not least, our most important institute here in this project, IZM, who taking care about reliability, micro integration, and also does a lot towards sustainability. And then we have the two Leibniz institutes, Ferdinand Braun for Höchstfrequenztechnik, again high frequency technology, and the EHP, high performance microelectronics. So about the profile of this organization, as I said already, we are 13 Fraunhofer institutes, 2 Leibniz institutes. Together, if you combine the staff, we have more than 5,400 employees, almost 3,000 scientists working in this area, working for microelectronics. And you see also, that's also an important KPI for us, patents. We have almost 3,000 active patents on the field, not only on the field of semiconductors, but also on applications for it. We have quite a big space, clean room space, distributed over these institutes. So you see 19,500 square meters. And these clean rooms are equipped with a lot of tools. You may imagine that these tools are quite expensive, so we invest 2.2 billion euros in the equipment and the tools. Our annual budget, project budget, is about 670 million euros a year, and approximately 1/3, this is the Fraunhofer model, 1/3 is really applied research with industry companies. Yeah, you can see the topics: applied research, research on heterogeneous system integration, to get really, and that's really important also on EU level, the sovereignty of Europe, and we have CHIP Acts all across Europe, also across Germany and Bavaria. The FMD has a special commitment, as you all hear, on Green ICT. That's very important to improve the efficiency of semiconductors, also on the production side. We do a lot towards quantum computing and neuromorphic computing, chip design, but also chip integration or heterogeneous system integration. And last but not least, security is very important. Trusted electronics is also a topic we are working on. Yeah, project funded model, as I said, 1/3 is industry project. We always have a strong link really to industry, not only to semiconductor industry, but also to the applications, to industry who has the applications for the semiconductor. And yeah, very important, it is a distributed structure. So it is not one association, it's an association of groups of institutes. Each institute is working on their own, and but they are organized in this FMD structure. Yeah, and we also have a young talent program to support you and to bring you on board. About our technology, so the FMD is taking care of that the topics are distributed into 8 different technology platforms, starting from sensor systems. So we're also doing sensors on semiconductors, but also all the integration, characterization of sensors. Microwave and terahertz, I already mentioned. High frequency, we're going more and more to high frequencies. Even in the communication, we are talking now about terahertz communication, so it's beyond 100 gigahertz communication. It's very hard to handle this. You need the proper semiconductor technologies for it, and this is really an important topic. Then MEMS, microelectromechanical systems, so mechanical systems on semiconductor are getting more and more prominent. You may know them from sensors you have in a car, acceleration sensors, for example, they are based on MEMS, and these are really important topic, not only for actuators but also for sensor systems. CMOS still there, still the most important technology for digital design. Power electronics are coming more and more, efficient power electronics, also the material for it, especially for electric cars. You can imagine you need really efficient electronic for drives. Optoelectronics, yes, high-speed communication system, backbone systems, they require optic electronics also on semiconductor basis, increasing communication speed up to terabit per second. Very important topic for the backbone, for the internet backbone. Then chip and chiplet design, so that's a new topic as well, to stack devices, chips into a single package, so that you have logic parts in one chiplet and you can combine them in the integration on different layers. And last but not least, multi-project technologies. So this is also if you have, for example, projects where you want to combine or want to have wafers on one, multi-projects on one wafer, then you can do this, prototyping, verification, and also manufacturing. Yeah, we have also a cooperation with universities. Here you see an overview. You see the distribution of the FMD institutes, and every institute has its cooperation with a university. I will not go through all, but here in Nuremberg you see we have IIS and ISB. We work close together with the University of Erlangen-Nuremberg, Friedrich-Alexander-Universität. So Professor Albert Heuberger, who could not be here today, is chair, and also Professor Bernhard Grill. And here in Nuremberg we have a new university, TU Nuremberg, just recently, or UTN Nuremberg, I would say. And Professor Alexander Martin is responsible for this location here, has also a chair in Nuremberg. Okay, yeah, what we are contributing for the future, what are most or very important topics in the future? Well, mobility, you may know, electric cars, they require more and more semiconductor power for power and also for all the control and charging stuff. Then production technology of the future, also important. Communication, we have a lot of communication expertise, also here in our institute, but also in other institute, HHI. So working on also in standardization for cellular network, mobile phone, next generation 6G, 5G communication. Then next generation computing, that's a really important topic about running AI algorithms, so specific hardware, neuromorphic hardware for running AI, optimized for AI, but also quantum-based computing is one of the topic. Sustainability, that's why we are here. So we want to make everything more efficient, not only the electronic itself, but also the production, more sustainable. And last but not least, security is always an issue. If you have a lot of distributed electronic devices, you want to be sure that they're also secured. Now coming to this project, Green ICT, and also how it is organized and why you are here. So Green ICT at FMD is a project, a very huge project, Competence Center for Sustainable Information and Communication Technologies, the main topic. 12 institutes, 12 Fraunhofer Institute and 2 Leibniz institutes out of the FMD group. So you see that only one is missing. Are part of this project. It's funded by the German BMBF, so Bundesministerium für Forschung, for research. It's a quite huge project with almost 34 million euro of funding. And you see that we are almost at the end. So runtime is January next year. So we have a little bit more than 9 months, 10 months to go. And yeah, you see all the partner institutes there. Why is it important to think about or to improve about ICT, information and communication technologies? So you all may know, or you may experience that information and communication technologies are becoming more and more relevant in your daily business. So on your smartphone, on your computer at home. So, and the electricity consumption of ICT is quite large and still growing. And if you look how they are distributed, then you can see public, okay, a little bit. And then you see telecommunications, so all the communication part, cellular phones, but also at home. We are all surrounded by communication networks. They all require energy, and you see also that they will slightly increase. Also the households, smart homes, there are more and more ICT technologies at home, networks at home, and they will also increase roughly. But the most important or the most driving factor is really data centers. So more and more applications are running in the cloud, more and more AI is coming up, and they require a lot of energy. So we expect that it will grow dramatically by 15% over the next 10 years. And that's the reason why it's important to think about how can we make these technologies more efficient, more energy efficient, more sustainable. So ICT results in or takes 1.4% of the global emissions worldwide and 4% of the global electricity consumption. But also we have a topic of, no, it doesn't work anymore. Semiconductor factories also consume a lot of resources, not only electricity for the production of semiconductors, but also, for example, waters or other chemistries. So the ICT, the Green ICT project FMD not only takes care about reducing electricity, but also to save resources like water. And that's the key topics of the project. The project is organized, as I already mentioned. We have the 13 institutes, the FMD, organized in FMD, and we have 3 technology hubs. One, which we are mainly focusing here the next week or this week, is the Sensor Edge Cloud. You will hear more about in a few minutes. Then we have one hub about communication networks. As I already mentioned, very important topic, new communication, 5G, 6G, optical communication. These are all very important. And finally, our third hub is taking care about all the production of microelectronics, semiconductor, to reduce, as I said, the energy for producing microelectronics, but also reducing the resources which are required to produce them. And we have some complementary activities. First one you see there are the camps we are organizing here, and the second camp we are organizing here. But we have some other activities like standardization, open platform, and Green ICT Connect, where we organize also events where you can present your ideas. So that's it about the project. Welcome to this event, to this 1 week. And now I would like to hand over to Nadja to give you some organizational hints how this week will be done. Yeah.
Sure. Thank you, Josef. Let's just